Hey, honors physics students, we're getting ready for the Chapter 6 test, and I thought you might enjoy a little video of showing you how to solve a couple of the problems on the extra review. If you look at number 1, this is an object going in a circle. It is Frank in his car. The car door prevents him from flying out. A couple things to look at. If you look at the circle that we've got here, we have information about a quarter of the circle. So recognize that we need to have the entire circle. So for instance, if you see t equals 7.1 seconds, let's write that as lowercase t equals 7.1 seconds, then capital T is 4 times that. Now 4 times the 7.1 would be about 28.4 seconds. So that's the time it takes to go all the way around one time. Now notice another thing. The weight is 850 newtons. Now remember, weight isn't used in this formula. Weight is mass times the acceleration of gravity. So mass is going to be his weight, 850 newtons, divided by 9.8 meters per second squared, and that should give you a mass of 86.7 kilograms, approximately. One last detail that's very important is that he travels a distance of 72 meters going all the way around the curve. So he goes around the curve 72 meters. Now that 72 meters is not the entire circumference. So 72 meters times 4, because it's a quarter of the circle, would be 288 meters. So if you divide 288, so if you set 288 meters as the circumference equal to 2 pi r, you can get the radius of 45.8 meters. So we have the radius of the circle he's going in. Now we're very close to being able to solve for the centripetal force. What force is applied? There's a centripetal force. At every moment, that centripetal force is pulling toward the center of the circle at every single moment. And the centripetal force formula that has T as well as R is m4 pi squared r over t squared. Now remember, the most common error in this circumstance is to forget to square the t. So remember to do that. We have all the other units properly placed, and you get about 190 newtons as the solution to that. So that's number 1. How about let's look at one other problem. If you check out number 2, it's a very good problem because you can get a lot of information from this. So the rock is thrown at an angle of 35 degrees. So we have 35 degrees. Of course, it is thrown with a VH and a VV1. But notice the very important issue. At the top of its rise, the velocity is 18 meters per second. Well, 18 meters per second is the velocity horizontally. It has no velocity vertically at the top. So basically, we are telling you that v sub h the whole time is 18 meters per second. And then we could use the formula vh equals v cosine theta, that is 18 meters per second equals v cosine 35, to help us get the velocity, the starting velocity. So that means then that v, the velocity it starts with, is 21.97 meters per second. Let's write this, 21.97. The VV1 can be found by VV1 equals V sine theta. If you take V sine theta, you should get 12.6 meters per second for the VV1. Of course, when something is thrown and it goes up and down, time to the top is very useful to do. We do 0 minus 12.6 over negative 9.8 produces 1.29 seconds. Okay? Now, this question is asking about the height. When it travels up and down, it only rises for the time to the top from there to there. So we will use that time to the top in the d sub v formula because we want to know how high it goes. The d sub v is equal to vv1t plus 1/2 at squared. The vv1 that we discovered is 12.6. The time is 1.29. plus 1/2, and what's fighting against us is the acceleration of gravity. Up is positive, so gravity is negative 9.8 meter per second squared times 1.29 seconds squared. The dV becomes 8.1 meters, and that's the solution to this problem. That was enjoyment. Thank you.